Good afternoon, everyone. Let's get started. So, I want to point you to a very good resource. This is posted on eLearn site. So this is a 45-page handout on Essential C. This is from Stanford University. So this is a fantastic handout, and you should read this handout very carefully along with the textbook. So for example, this wouldn't have any examples or anything, but this is a very good reference. If you have any doubt, you can quickly check this resource. And so two important resources, one is your textbook and the other one is this handout. And I want you to read by end of next week, section 1 and section 2. Section 1 you should already read. By this week itself you should read section 1, and maybe by end of next week you should read section 2 also. And in some sense they form the core components of C programming language. And of course, by the time we finish the course, you should read this whole handout carefully, thoroughly, so that way you will have solid knowledge. One thing I strongly, how much of the book should we read? Read everything as in the book, Aryan. So that's the best way to get knowledge. The book is fantastically written, so read it slowly, read it carefully. It will not be possible for us to know to discuss all the details that are there in the book in the class. Uh, but you should read the book carefully. It's an excellent book. And you should self-study, self-learn. So all core ideas will be, that is the textbook. The e-learn, we will fix it. So this essential C and that book, that your textbook, you should read very carefully. So yeah, so what I strongly discourage is don't keep Googling stuff and try to read here and there, because you don't get a comprehensive picture of the story. So unless you read the textbook, unless you read this essential C resource, you don't get a very good picture. Your foundations will not be solid. So that's the reason. So please, again, I insist, read the textbook, read this book. So this week you should read section 1. By next week, you should read section 2 also. So now let's get started with our discussion. Let's go. Yeah. So now let's look at, so in the last class, we have studied if statements and Goto statements. And in this class, we will revisit those ideas, get a more thorough understanding of those ideas, and look at solve one or two problems and get a good feel for these ideas. All right. So let's start with a simple program. I call this as, we start with an extremely simple program, which I call as stride.c. So include So in this program, so let's say I have two variables, couple of variables int I, j, and then I say I is equal to 2, j is equal to 2 star I plus 1, and then maybe I can again have I is equal to j plus I, something like that. So there is no logic to this code, just some sequence of statements. So now let's compile this program. So let's compile this program and see what happens. So the program name is stride.c. You compile stride.c. You get a warning, the return type is not defined properly. So let's make this void so that the compiler wouldn't give a void. Means the function doesn't return any value. We'll understand it a bit later, but let's take take that word from me for now. So now there are no, so when you run this program, what will be the output of this program? What will happen when we run this program? Nothing. Yeah. So some computations happen, you don't see anything. Okay. So you don't see, since there is no printf. So now in today's session, we will see a very important tool called as debugger, GDB. So we use GCC in order to use that tool, the debugger tool. We have to compile our program using a flag called as -g. You can see now I am compiling straight.c using -g option. And also I'm just using O just so that, for fun, so that the generated executable will be written into the file straight. So the file straight contains the machine code equivalent to straight.c. It not only contains machine code, since we are using this debug flag, it contains some more information which enables the debugger, right? So now let's see how this debugger works. The command for debugger is GDB. The tool name is also called as GDB. You say GDB straight. This is the program you want to debug. So you will say GDB straight. So now so you get this GDB prompt, and if I say run, the program gets executed. So the program got executed. We are out of the program also. All right. So yeah, it's not going to help us if this is all we can do using GDB. But what we can do is we can control the program execution. Like for example, I can put what is called as a breakpoint on the beginning of the function main. When I say break main, you can see the message here that there is a breakpoint 1. So you can put multiple breakpoints. Every breakpoint gets a number. Since this is the first breakpoint, it gets the number 1. So you can see that breakpoint 1 is set in the file straight.c at line number 7. So if you see, the first statement in the function main is on line number 7. So because of that, when we run the program, so GDB, what it does is it executes all the instructions of the main, and it stops before executing line number 7. And what happens to line 5 int ij? So why the breakpoint, when I said the breakpoint mean, why the breakpoint is not set on line number 5? Because line number 5 is also a statement in main, right? Line number 5 is also a statement in main, right? Why is it not setting a breakpoint on line number 5? Isn't it the first statement? The breakpoint is right before the second statement. The reason is the line number 5, there are no instructions associated with line number 5. There are no instructions associated with line number 5 in the executable code. You are telling the compiler that in your function main, you are using the variables I and j, and their type is integer. But there are no instructions associated with the statement 5 on the line number 5. No, this int ij, it's a statement in C, but there is no equivalent assembly code or machine code because the processor doesn't care about ij and all those things. But compiler just looks at statement 5 and it understands that in your program, in the function main, you are using the variables I and j, and their type is integer. Are you with me here on this? This is an important observation. That's why I'm emphasizing this. Are you all with me here? There is no equivalent assembly code or machine code for statement on line number 5. It is better if you type the questions instead of raising a hand. Vitish, can you ask your question? We will see. So I will show uh, uh, we'll make few. You'll get to learn GDB. I mean, we're just getting started. When does the initialization happen? During compilation. The initial good question with is the initialization happens during, not during compilation, during execution. No, in assembly code, see I, J and all these things, they are mapped to memory and registers. So in the assembly code, there is nothing like I, there is nothing like J pretty much. But I and J, we need to tell the compiler what I and J are, whether they are variables, no, whether what kind of data you are storing in I and J. All this is required for the compiler, so that when you do something like I plus J, whether uh, to what instructions it should generate to add these two variables, for example. VS Code has a debugger, but we will not use the debugger, but we will use GDB. VS Code uses GDB underneath, but I would like you all to use GDB. VS Code can use multiple debuggers. GCC minus G, it's a, let's get going and then I'll take your questions again, okay? So at this point, I want you to point out how to use this, take a small detour and explain how to use this reference manual. Like for example, in this program, we are working with integers on line number 5. So if you want to know, hey, what are all the integer variants of integer data types that are available, if you go to this reference manual, you can quickly see that there are short integers, there are integers, and there are long integers, and there are unsigned integers, and by default, everything is a signed integer. All this information you will, and the minimum number of bytes allocated to a long integer is 4 bytes. And so like this, all the information associated with integer data type, you will quickly get a summary if you just read this. So I want you to use this reference cleverly as you write your programs to quickly understand, when you get a problem and to get a quickly refer, hey, what I should be doing, or whether what I'm doing is right or wrong. Of course, textbook is there, but this is much faster to refer because in textbook there will be an explanation and but if you want to quickly refer, you can just refer this reference. All right, so let's go back to our problem. So this is our code, and let's look at GDB. Okay. So now let me start again. What is Control L? So GCC minus G. In order to be able to debug your program using the GDB uh, uh, tool, you should compile your program using minus G option. This is minus G is what is called as a compiler flag. Using minus G option, you should compile your program, and then you generate your executable in a file called as straight. Step 1, are you with me on step 1? So GCC compiles your program, the minus G flag adds some extra information to the straight, to the object or executable file straight, which facilitates GDB to do the debugging. So GDB is a real debugger. It's the tool. So we say GDB straight. Great. And then, as I said, if you just run it, the program runs. It's not of much use to us. So we have to put a breakpoint. We said break main. So when we say break main, so it says the first executable statement in the function main is on line 7. So there is a breakpoint is set on line 7. So now you do run. So now when you do the run, it says, the program runs, and the important thing for you to observe is it stops before line number 7, and it prints the statement on line number 7. So this is the statement that we are about to execute. It's not yet executed. This is not yet executed. This is the statement that needs to be executed. And then, so we use this command, GDB command next. Ananya has a good question. Would it break at line 5 if we said int I is equal to 2? Maybe, yeah. So you should check. Good question, Ananya. So and then we say next. So when we give the command next, the statement on line 7 got executed, and the next statement is present on line 9, and that gets printed. Because the program stopped on line 7 because we put a breakpoint here. This is what I explained. We said breakpoint, break on function main. The first executable statement in function main is on line 7, and that is where it stopped. And now so after executing line 7, if you print I, you can see that the value of I is 2. And now we didn't still execute. This is not yet executed. So this line number 9, it is not yet executed. This is also not executed yet. It is about to be executed. So if you print J, so right now it is printing 0, but it can be any garbage value. But let's say if I do next, and then if I print J, you will see J is equal to 2 times 2, 4 plus 1, 5. Are you with me here, the steps? How we are able to control the program execution, print variables, etc. Are you all with me? So now if you can see, the next statement that needs to be executed is the statement on line 11, and that's what it is being shown here. Statement on line 11 needs to be executed. So now we will do next, and then so and then if I do print I, you can see 5 plus I is equal, earlier I has 2, so 5 plus 2 is 7, and it showed 0. It's not initialized, so it can be any garbage value. It just happened to be 0. So before computation, when we print J, it can be any value. Are you all with me in this example? So let me run through this again. So let's go back again. So what do? You compile the program using -G option. You compile the program gcc -G straight.c -O straight. Are you with me on this one, the compilation, how you compile and do? One step at a time. Yes. What is the next command that we should be using? Just not GDB. We should use GDB, whatever the file that you want to, executable that you would like to debug. You do GDB straight. Now, I will introduce one small thing which make your life slightly easier. There is TUI enable. Yeah, we can use GDB dot straight. Yeah, no problem. And then we set a breakpoint on main. And then we do run. Don't worry, don't try to remember these commands. On your eLearn site, today I will post what is called as a GDB cheat sheet. If you read a GDB cheat sheet, you'll completely understand this. So we use GDB, so TUI enable, we set a breakpoint, we run. So now you can see line 7 is highlighted. That means line 7 is about to be executed. So now if I print I, It turns out to be 0, but it can be anything. There is no guarantee on what the value of I and j is. Are you with me here that we are before line 7, when we print I, there is no guarantee of what I contains. But it turned out to be 0 here for some reason. Yeah, why is there a control question mark at the end? I am not sure. There is nothing like using a garbage value. So it depends on why, on many things, but let's not worry about it. Okay, all I want you to understand is we cannot take for granted what the value of I and j before we assign anything to them. Okay, are you with me there? We cannot assume that I and j will be 0. We cannot assume that. They happen to be 0, but they need not be 0. So now, after we execute line 7, what will be? I am pressing next, indicating that execute the statement on line 7. And then, so what will be the value of I? So now we can do print I, it will be 2. Now I use next and then print j, it is 5. And then again we use next, and then when we print I, it will be equal to 7. Does it make sense, guys? Are you with me? Great. Don't worry about the $1, $2, whatever. No, it's, so just what is it that is getting printed? So Vitish, nothing is going to happen. The same thing. It's GCC. You just use GDB dot straight or straight, all the same. On terminal, we don't get any output, right? So because this program doesn't have any printf statements. So now let's try to run this program again from the beginning. I said run, and then it again came to the beginning. And then I will say next. So when I press enter, the previous GDB command gets executed. What is the previous GDB command? That is next. So when I press enter, then you can see that statement 9 got executed, and then it went to statement 11. So if I press enter again, then statement 11 got executed because the previous GDB command is next. Are you all with me here so far? Does it make sense, the whole story? And again, we can start debugging by saying run. And it says start it from the beginning. Yes. I want you to know, when you are learning, maybe it depends upon the GDB version. So you should try to get the core idea. There could be some variants. Don't worry about them. The core idea is your ability to step through the code by setting up breakpoints, your ability to set breakpoints, your ability to, uh, uh, step through the code one after another. All these things, these are the important features. In fact, you can also use what is called as a watch command. I can say watch I comma j. So whenever the variables I and TUI space enable for, yeah. So if I set up this hardware watch points, whenever these variables I and j are modified, they will be printed on the screen. So now we are on line 7. So I say next. Why is the watch point not okay? So the value of I changed. Yeah, the value of j changed from 0 to 5. So because of it got printed on when we executed its statement. Okay, I think let's do one thing. Let me, yeah, let's do one thing. GDB straight again. If you want this, it's the same. TUI enable, break main, run. I will say watch I, watch J. So whenever the values of I and J change, I think it should print on the screen. Let's see if it happens or not. Yeah. So now, the value of I got changed. So it's automatically printed on the screen. So the new value of I is 2. And then next, the value of J, change it from 0 to 5. The new value of J is 5. And then we do next, the value of I, change it from 2 to 7. So it got printed on the screen. Are you all with me here? What are the 3 things that we have seen? So how to step through the code using next, how to step through the code. So these are the ideas that we have seen. Number 1, that we can set breakpoints. And then we can set watch points. Number 3, we can use next and step through the code. Are you with me on these 3 ideas? Are you all with me? You don't need to exactly worry about the exact commands, etc., because I will post the handout, but if you conceptually are with me, that's good enough. You should be able to do it by. And then there is one more thing. In order to have a better thing, you can use TUI enable. So the watch point part is very simple. When the value of a variable changes, it prints on the screen automatically. Otherwise, what are we doing? We are kind of print. So we are doing the TUI enable will display the whole this whole window that you have here, where we are able to see the source code that comes by using TUI enable. So the question is on. So can someone put on the message chat box? What is the purpose of watch point? You tell Anirudh, what are we doing here? No? You should all pay attention. So there are 2. I have one. There is one question. What does watch point does? Yeah, so Rahul, you got it right. You don't have to print the variable. If you are interested in how the value of the variable I is changing, then you don't have to print I every time you do. So only when the value of variable I changes, automatically it gets printed. And if you see the commands, we are specifically using watch commands. Not all variables will be watched. Only the variables that we would like to watch will be watched. Let me do one thing here. So again, GDB break. So to enable, the screen comes up. Put a breakpoint on main. Run. So now I will put a watch point on J, but I don't put a watch point on I. So now because of that, when we executed line 7, the value of variable I changed, but it's not printed automatically. So if you want to know the value of variable I, we should print I. But since we put a watch point on J and the value of J is getting changed on the statement 9, when we execute statement 9 using the next, then automatically the watch point gets enabled. It says the old value of J is equal to 0, the current value of J is equal to 5. Are you with me now on the watch point stuff? Yes or no? Okay, I think we should keep going. There's a lot more cool ideas that we have to see now. So how do we execute GDB? Control D, quit. Quit command you'll quit from GDB. So now we will make this code more interesting. So now let's say I have something like go to L1. statement, and L1 is equal to this. So now if I execute this program, what will happen if I execute this program? It gets into an infinite loop. Very good point. So let's see. So you see GCC straight.c, and if you do .a .out, it runs forever. Good. So it keeps running forever. So now this is the first time. So yeah, in the last class also we have seen, of course. But the point is, so in the earlier code, you execute statement first one statement, and then you execute another statement, you execute another statement, and then you say you have a statement like go to L1, and where L1 is attached to this, then what happens is when you hit this, control goes here. And again, you keep coming down, you hit go to L1, you go back, and then again come down. This is what is happening here. So now let's try to debug this code, trace this code using GDB. So one thing I want to tell you guys is usually most of you end up debugging code using lots of printf statements. While it is all right, sometimes it gets too clumsy. An elegant way to finding problems in your code is by making use of GDB. Right? So GCC minus G. So now you do GDB straight. Huh. See, now it is running forever GDB because I didn't put a breakpoint. Do you see what is happening? I didn't put a breakpoint and the program is running forever in the GDB. Are you with me here? So now I have to do Control C to terminate. When I did a Control C, the program is executing statement 11, so it stopped there. And let's see what is the value of I. So the value of I, when I terminated the program by using Control C, it is a huge value. And if you look at J would be negative possibly. Yeah, it's huge value. Does it make sense how all these things works? Isn't it fun? Like how you can get into things and do. So now, yeah. So in order to get a good understanding, so let's say you put a breakpoint on main. So we can use B as a shortcut and start running the program again. Yeah. So you start running the program from the beginning. So now we are on line 7. So now you use next. So you go to line 11, and then again I am pressing enter. So the previous GDB command, which is next, gets executed, and then you press enter. You go to statement 15. You press enter. You go back again to statement 11 because L1 is attached to statement 11. So you keep going like this. It keeps going forever. You will be in this loop forever. And then let's see what is there. Print I is some value, print J is some value. Great. Okay, so now move on. So now we want to take a look at the if statement. So let's exit from this program. We can use Control D also to exit from GDB. So yeah, there is a possibility to get a negative value. You will understand later why you get a negative value. Good question, Aditya. Yeah. So the next thing that I would like you to understand is what is called as a conditional statement. Yeah. So we now look into what are called as uh, relational operators. So let's say, so what is a relational operator? A relational operator can be applied to two integer or floating point values, and they return either 0 or 1. and they return. So this handout is already posted on the e-learn, and they return either 0 or 1. Like for example, let's say if you have something like so before we look at relational operators, so earlier you have seen arithmetic operators. Arithmetic operators. Arithmetic operators, addition, subtraction, multiplication, division, remainder, so on and so forth. These are arithmetic operators. So now we are looking at the relational operators. So if you have something like a equal to 4, so if a is equal to 4, the value, a Boolean value, so 1 will be returned and otherwise 0 will be returned. So if you want to look at a tree representation for this, so the operator is equal to, and no, this is how it is. This is left and this is right. This is the operator. So if a is equal to 4, if a is equal to 4, then what happens is this. So 4 is equal to 4. The value here that you get is 1, which is equivalent to true. In C programming language, non-zero means, in C, non-zero means true, and 0 means false. So here, while it is written, supposed to return 1, we are not guaranteed. It can be any non-zero value. So we should not rely on the fact that a equal to 4 and may return 1. We cannot write programs assuming that this may be equal to 1. Are you with me here on this particular thing? Are you all with me? And on the contrary, let's say if a is equal to uh, if a is equal to 3, if a is equal to 3, then 3 compared with 4, it's not no, it's not equal to, the value written will be 0. This is how it works. And similarly, not equal to, no, it's this is like so a not equal to, let me use it of my original. It is possible to, it may return other than 1 also. It is little bit compiler dependent, I guess. So let's not, so we should not rely on the fact that it will return 1 if it is true. So don't rely on it. So similarly, you have greater than, less than, greater, all these uh, relational operators. Are you with me on the relational operators? Yes or no? Good. So now you may want to, while writing programs, you may want to have multiple conditions together. So there you need to use what are called as logical operators. So these are the logical operators. One is not, one is and, other is uh, Boolean, other is or. These are called as Boolean not, Boolean and. So let's say if the truth value is true, then if you apply this Boolean not operator, it becomes false. And if it is false, it becomes true. So like for example, a equal to 4, what is the equivalent condition? So this is equivalent to not of a not equal to 4. Does it make sense? Like for example, if a is equal to 4, if a is equal to 4, then what happens is this will return a true. Let's say this returns 1, and so this will return false because 4 is not equal to 4, it is false. But when we apply not operator, what happens is this false becomes true and this becomes equal to 1. Similarly, let's say if a is equal to 3, then 3 equal to 4, this is false. So because of that, we get 0. And so, but 3 is not equal to 4. So when if a is equal to 3, this is true. So if you apply negation of true, this will be false. So this and this match. So both these statements are equivalent to each other. There should be one more in the brackets. I think this is all looking good. This is not operator, guys. So we are good only. Yeah, we can store the returned value in some other variable. Perfectly fine. Good question. So now one more thing now. So let's say you want to check and I want to have some, let's go back to our, I have some space here, or maybe I should use, yeah. So let's say we want to check if 0 is less than or equal to a is less than or equal to 10. How do we do this? If you want to check this condition, so what we have to write is 0 is less than or equal to a ANDed with a is less than or, sorry, a is less than or equal to 10. So the tree representation, I want you to understand this tree representation as this is very useful. Less than or equal to. So again, less than or equal to. So now let's say if a is equal to 4, then let's see how the values propagate. So a is equal to 4. So a is equal to 4. So 0 is less than or equal to 4. So this is true. So this true gets propagated here. 4 is less than or equal to 10. So because of the true gets propagated here, true ANDed with true is true. So we get true. Are you with me on this example? Before we look at new scenarios, so I just want you to understand how we are converting this expression into a tree. Are you all with me here so far? Great. So now let's look at a different scenario. Let's say the value of a is equal to the value of a is equal to -1. If the value of a is equal to -1, so -1 goes here, 0 goes here. Is 0 less than -1? False. So once it is false on this side, then the compiler knows that there is no point in evaluating the right subtree, because false ANDed with whatever it is, it will be false. So this part will not be evaluated. So the right subtree will not be evaluated. This is what is called as a short circuit evaluation. Short circuit way of evaluation. That is, there is no necessity to execute this part. So only the left part will be executed, because once we know it is false, it is done. Are you with me on this example? You're all right? You're all right here? Okay, good. So now let's look at OR condition. So let's see what's the story if it is OR. So if it is OR, then what happens? So if it is false, then the value of this whole expression tree depends upon whether the value of the right sub-expression, the expression tree, is true or false. So because of that, the right part will also be executed. So you use the value of k is -1. So you check if -1 is less than 10. So it turns out to be true. So false ORed with true is true. Great. So good question, Srijan. So now let's consider the different case when A is equal to 4. When A is equal to, yeah, let's say if A is equal to 4, what happens? If A is equal to, yeah, that's true. Let's consider the case where A is equal to 4. If A is equal to 4, yeah. If A is equal to 4, 4 comes up here. So 0 is less than or equal to 4. So what, let me wipe all these things. Yeah. So 0 is less than or equal to 4. It becomes true. Since this is true, there is no need for evaluating the right expression tree, because true ORed with whatever it may be, it will be true. Because that is the precedence. So when we have things, we will start, that is the precedence. That's how the rules. We have to either execute left part or right part first. And the convention that is used is we execute the left part first, followed by the right part. Are you with me here till this point? Does it make sense? And then there is one more interesting question that is being asked in the other session. That is, what if we have even ORed with E2 ANDed with E3? So here we have to look at the associativity property and precedence property. I think both have the same precedence. I don't know. You have to check. Based on that, the grouping will happen, because there are two ways of grouping this. One is even ORed with, we have to look at the manual, but I think they have the same. This is one way. An alternate way is the even ORed with E2 ANDed with E3. So is it? Let's look at the precedence. Yeah, I don't know the precedence actually. Uh, so precedence, it looks like and has a greater precedence than, it looks like and has a greater precedence than or. So because of that, the grouping will happen like this. I'm saying if you just write something like this, there are two possible ways of evaluating this. This is one way, this is the second way. And if both these have the same precedence, and if it is left associative, then we have the first one. But on the contrary, if this Boolean and has a higher precedence than Boolean or, this is how it works. If they have the same precedence, then it will evaluate from left to right. Assuming, so I want you to check, assuming, I'm assuming this, assuming the precedence of Boolean and is greater than the precedence of Boolean or, the way this will be evaluated is like this: or, even, and E2 and E3. Are you with me here? I want you to check this one. I want you to check this thing. Check in the book, check whether this precedence condition is right or wrong. Are you all with me? Happy so far? Doing good? So now in this context, So what happens is if the value of this expression is true, if the value of the expression is true, this whole right subtree will not be executed because this is an OR operator. And similarly, let's say on the contrary, the value of this is equal to false. And because of that, this needs to be executed. And if this is equal to false, then we don't need to execute this one because false ANDed with anything is false. So we just propagate false up. So this whole thing is the short circuit evaluation. Does it make sense? A false here implies we still have to evaluate this subtree, but a false here implies no, that we don't need to evaluate the expression E3 because false ANDed, Boolean ANDed with anything is still false. Yeah, first E1 is executed because it's from left to right. Okay. So now let's go back, clear all my drawings, and let's look at this document. So I want to review the if statement. So before we review the if statement, I want you to understand one thing. So far, we are looking at statements, simple statements such as, I is equal to j plus 1, so on and so forth. So we can group statements and form what is called as a compound statement or a block statement. Compound or a block statement. So that is, we can have something like I is equal to j plus 1, j is equal to 2 star I, etc. So this is what is called as a block statement. So if you see the if statement here, there are two forms of if statement. One is if statement without else, and one is if statement with else. All right. And if there is that statement can be the statement after, if you see here, if followed by statement, this statement can be a simple statement or a block statement. So what would be a simple statement? Like if some condition, if a greater than or equal to 4, then I is equal to I plus 1. This is a perfectly valid statement. This is a simple statement. This is an if with a simple statement. But it is also possible for us to have something like this. It is also possible for us to have something like if a greater than or equal to 4, have something like I is equal to I plus 1, j is equal to j star I. So this here we are using a block statement. Does it make sense? Are you with me here? And here in the if part, we can not only use the conditional expression, we can use not only what I would say, any expression we can use. These expressions, they don't need to be necessarily of the form if a greater than or equal to b, not like that. It's not necessary. Because what happens is whatever the expression that is there, it gets evaluated, and if it is a non-zero value, it is treated as true, and if it's a zero value, it is treated as false. So here it is quite possible for us to have an arithmetic statement such as if a plus b, as simple as that. So if a plus b, if they are, if the sum of a plus b turns out to be 0, then it's a false. Then it will be treated as false condition, and if it turns out to be any value other than 0, it will be treated as a true condition. We cannot have nothing in the expression. It is required. You will get a syntax error. Are you with me here? Are you all with me? And the next important idea here is this. Like for example, this thing is called as conditional expression, or what is called as a ternary operator. Let's say you want to find max of two numbers. You can say a greater than b, then return a. sorry, otherwise written B. So here, this is expression E1, this is expression E2, this is expression E3. So this condition will be evaluated, and if this is true, then the value returned by this expression E2 will be the value of this whole expression. And on the contrary, if E1 evaluates to false, this is question mark, question mark. If E1 evaluates to false, then the expression E3 will be evaluated, and that will be returned as the value. Are you with me on this one? This particular example? Yeah, so we don't need to put semicolon at the end of a block statement. No. I hope you're all with me here. And the equivalent code for this, where is this useful? Because we don't technically need this, because we can as well write the code as if A is greater than B, then you say max is equal to A, else you can say max is equal to B. You can write this. Or if you want to even make this shorter, you can say if A is greater than B, then max is equal to A, else max is equal to B. So either you can use this code or you can use this code, but you can see that there are at least 4 lines of code. Instead, you can write this using a single line. So all these three are equivalent. So this code sequence, this code sequence, this code sequence, all these three are equivalent. Can you see the equivalence between these three statements? Are you all with me? Yes or no? Okay. Number one code is very simple. So what is the semantics? It's as simple as that this expression A greater than B is expression 1. You evaluate expression 1. If it turns out to be true, then the return value is the value of expression 2. Expression 2 here is A. Expression 2 here is A. And expression, if it is false, then expression 3 the value of expression 3 will be returned. The expression 3 is nothing but B. We need not write any expression before max or syntax. I didn't get your question, Anjali. What is your question? In which case? No, in case 1, you don't need. Here, you don't need any if else here. Here, you no need for if else. That's the whole point of writing code in that fashion. So you're all good. Shall we go ahead? Shall we keep moving? We'll try to solve the homework problems. We'll solve a couple of homework problems. And is it all right? We will require, let's say, 15-20 minutes. Okay. Clear all my drawings. Just give me a minute. I will be back. I just need a 1 minute break, and then I'll take it up. Just 1 minute, guys. You may also want to get some water or anything, and then we'll continue. Okay, let's get going. So let's start. Let's go back. So our first program that we are going to write is, so we want to compute sigma I is equal to 1 to n I. This is what we would like to compute. And we read n from the input. This is our goal. So what do we do? So we just have this. Sum n dot c. So now what we do, so first thing is printf, enter n, and great. So we need to read the value of n, scanf %d and %n into value of n. And then we would like to use a variable sum to accumulate the sum of values. So let's use a variable sum. And then we will initialize the value of the sum is equal to 0, right? And then, yeah, so what do? We use one more variable I. We use one more variable I also. So let's say, yeah. So what we do is I is equal to 1. I is equal to 1. And the condition that we do is if I is greater than n, if I is greater than n, we say go to end. So whatever end is. So let's say down the lane somewhere here we have end, and we have to end should always point to some statement, and this is what is called as a yeah. Let's put it as a. We'll revisit that later. Otherwise, what do? So we do sum is equal to sum plus I is equal to I plus 1, go to L1, and so when we reach end, so we say printf sum of first n equal to %d numbers is %d slash n sum. And where is L1? So where should L1 go? Where should L1 go? What should the label L1 point to? Before if and after I is equal to 1, right? Does this make sense? You're all with me here? Not line 10. So the initial value of sum is equal to 0, and as we keep looking at i's, we keep accumulating I. But otherwise, if sum is not equal to 0, then how do we accumulate sums? The initial value of sum is equal to 0. And as we see more and more i's, we keep accumulating them in the variable sum. Are you all happy with this code, the whole code? Makes sense, right? Yeah. So now let's control L, GCC, sum n dot c dot, yeah. The value of first 10 numbers is 55. Okay. Are you all good with this code? Any doubts on this code? Are you happy with this code? What is sum? You tell me, Tarun, what is sum? What are we using the variable sum for? Sum is a variable. What is its type? It's an integer. We are accumulating the sum. So this is what we are doing in the loop. So initially the value of this is sum, and initially, so let's say this is when so when variable when I is equal to 1, we in the sum we accumulate 1 into sum. When I equal to 2, so we add this 2 to sum to get 3. When I is equal to 3, we add 3 to the sum so that it becomes 6. When I is equal to 4, we add 4 to the sum so that it becomes 10. That's what we are doing on line number 16. Are you all happy? Anyone having serious troubles, you can send me a private message. What is plus equal to? It's not discussed in the class? What is plus equal to? Discussed, not discussed? Okay. Yeah, so it's very simple. It's a shorthand for, you are not reading textbook, guys. Not everything will be discussed in the textbook, no? In the class. So plus equal to is a shorthand for sum is equal to sum plus sign. What is L1 colon? What are you doing in the last class? Harshul, did you attend last class? Number one, did you attend last class? Did you attempted the homework problem that is given? L1 is label, na? So that's what we have seen in the last class. If you did all and you're still asking this question, L1 is label. It can be anything. It can be, no, it can go to, it can be something like loop. L1 means label. I'm just using it as a label. Does it make sense? Does it make sense now, Harshal? Did it look like something for else for you? Because, if you did all the problems, then that's the essential thing. Right? Okay, good. Shall we move on and try to solve the next problem, the max problem? Just follow this line of thinking, Vitish. We cannot take a divergence, and you see there could be some error, and it can be figured out. Okay, check. We'll look at it later. Yeah, Anish, tell me. Yeah, here you don't need an else, right? So that's the. Why did we write I is equal? How do we iterate then? Because what are we trying to do? What we are trying to do is I is equal to, sorry, what we are trying to do is we are doing sigma I is equal to 1 to n. So how do we increment? How do we write a flowchart for this? So if you want to think about it in terms of flowchart, so this is our flowchart. You start with I is equal to 1, and then you check, if I is greater than or equal to n. And so there are two possibilities, yes and no. If it is yes, then what happens is your program has terminated. So this should not be greater than or equal to, this should be greater. I greater than n, and I think you are completely missing the point of this program. So you just print the value of sum here. This is the no path, and so what do we do here? So here we do sum plus is equal to I is equal to I plus 1. Then you go back here. This is the flow chart for it. Are you with me in the flowchart part? Okay, so you can compute this is equal to n into n plus 1 by 2. Why are we doing all this program? Okay, compute I power 4. Is there a formula for I power 4 also? I don't know. So is there a formula for I power 4? There's a formula for I power 4. For I power k, you have formula. It can be derived. Huh? Okay. Math.h. Come on. Okay. Anyways, so I think you are missing the point of this program. So what is it that we are trying to learn from this program? So if you really want to compute, no, this sigma 1, that thing, I don't even want to use the formula. Some software, they just give you the number, it gives the answer to me. So there is this question we don't require, else there will be lots of programs that we will be writing in this course. Soon you will start getting, you require else. So don't worry about it. So there will be lots of problems where as simple thing as if you want to find the sum of odd numbers rather than, yeah, this is the thing, guys. Can you find the sum of, if you want to find the sum of odd numbers, what do we do? Good question. So sum of odd numbers, we don't want even numbers, we want only the sum of odd numbers. Formula, I is equal to I plus 2. Good. Or you want to find only the sum of prime numbers, maybe. Okay, so while that's I is equal to I plus 2, it's a good strategy. Other way of doing it is you check the remainder, and if it is equal to 1, then you add, otherwise you don't add or something. We have to initialize sum to a value, Neha. So on line number 5, we have to initialize sum to a value. Because the numbers, when you declare numbers, you cannot assume them to be initialized to some values. We have to explicitly initialize them. Ketu, don't worry about using else. I don't know if we might be able to use get away by not using else, but that's not a big problem. Okay, that's what I'm trying to say. So we will hit problems soon where we need else part. Okay, we may not need else maybe for the problems that we have seen so far. I think we should pause here looking at the questions that you are asking. I think maybe you need some time. You want some time to think and come back to next class, or you want to solve the max problem? Do you want me to solve the max problem, or do you want me to? Min and max are same, Anirudh. It's not going to. Okay. So, okay, then let's stop here. Maybe we will take up the next problem, the max problem, in the next class. Uh, we will see, Srijan. Okay, I think we'll stop the class here. We will pick up the thread on Saturday. I will post, so on scanf, etc. I will post, you should watch the videos. I will also post a link for scanf, maybe if you read it, it might, if you watch it, it might help you. Okay. So let's stop here. We will pick up the thread on Saturday, and via mail. I will send via email. Okay. Okay then. Thank you guys. Have a great day. I think you should all put in more effort. I'm not sure if you are putting in more effort, and you need to know what to look for, and what to ignore and all that. So study hard, work hard. So yeah, it's reading helps. Reading helps. That's all I have for you anyways. So good day, and we'll catch up on Saturday. Okay, bye.